Okay, let's get into a really critical Kubernetes concept, requests versus limits.
Yeah, how do you stop one greedy app from crashing everything? It's a classic problem. Well, Kubernetes gives you two super powerful settings to fix this: requests and limits.
And trust me, getting these right is absolutely key for stable systems in production. Think of requests like a reservation. It's the guaranteed minimum your container needs to run.
Then you have limits. This is the absolute hard ceiling. Your app can't go over this, period.
Now, what's really interesting is who uses them. The scheduler looks at requests. The kubelet enforces limits. So remember this. Requests are for scheduling. Limits are for enforcement at runtime. Quick note on units. M is for milli-CPU, and you'll see MI for megabytes of memory.
So how does Kubernetes actually use these two values? It's a really simple two-step process.
First, the scheduler uses requests to find a home. Then, the kubelet enforces the limits. Okay, so what happens if your app tries to use more CPU than its limit? It gets throttled. Basically, it just slows down, but it doesn't crash, it survives. But what about memory? Oh, that is a completely different and much harsher story.
It gets killed, out of memory. The container is just terminated, instantly.
So there it is. Go over the CPU limit, you get throttled. Go over memory, you get killed.
With stakes like that, what's the golden rule for running apps in production?
It's simple. Always set both requests and limits for your containers. Because what happens if you just don't set any resources at all? Your pod gets classified as best effort. That's the lowest priority and the first to be evicted. Setting these properly is how you stop one noisy neighbor app from starving all the others. So the key takeaway is this. Are your limits actually protecting your apps from a sudden crash?